Hi, questions in thermodynamics. One mole of ideal gas initially at 10 bar pressure and 298 K is allowed to expand against a constant pressure of 2 bar to 2 bar final pressure. During this process, the temperature of the gas falls to 253.2 K. We wish to construct a reversible path connecting these initial and final steps as a combination of a reversible isothermal expansion followed by a reversible adiabatic expansion. To what volume should we allow the gas to expand isothermally so that the subsequent adiabatic expansion is guaranteed to take the gas to the final state? Show the desired process graphically as well, and label on your graph the initial, the intermediate, and the final states. Solution. The expansion one. We have this equation. Then we find the initial volume. Consider this expansion. We have this equation. The final volume is this value. Suppose that this gas is monoperfect. Then we get the gamma. Then we find the intermediate volume. We have this conclusion. Prove this identity. Solution. We have the definition for the capacity CV. Then we have this one. Write U as a function of V and T. Then V is a function of U and T, and T is a function of U and V. Then we have the equation 1 and the equation 2. Then we get this equation. This gives equation 3. Then we have this equation. We thus conclude this result. Initially 0.1 mole of nitrogen is at 1 bar pressure and 80 degrees Celsius temperature. The gas behaves ideally, and the ratio between the heat capacities taken at a constant pressure and the volume is 1.31. The gas is allowed to expand reversibly and adiabatically to a pressure of 0.1 bar. What are the initial and the final volumes? What is the final temperature? Calculate delta U and delta H for the process. Solution. We have this equation. So we get the initial volume. We have this equation. Then we find the final volume. We have this equation. Then we get the final temperature. Recall the definitions. Then we get the heat capacities, Cv and Cp. We thus obtain those results. Thanks for watching. Bye.